Okay, so we want to plot a solution of a function. Okay, so let's take one example. Okay, so format, style, title, plotting a function. Okay, function. Okay, so let's take an example. So for example, if the function is say cosine of y times cosine hyperbolic or cos x minus x is equal to 0. So this is the is equal to a constant value. Okay, so we have this, for example. So it is comes out like this, is equal to 0.35. It's because I was using something before, so I must clear those values. So for example, the value of c, or maybe I should clear the variables. Okay, so for example, the variables used are y. So to clear y, I will put y equal to dot, then enter. To clear x, I will go to x equal to dot and then enter, and then to clear c, equal to dot and then enter. And now all y, x and c have been cleared, and now I execute this command, and then yeah, I get this equation. Okay, so now I want to plot. So for plotting, it is we need to plot it in terms of y. So we can write this equation in terms of y also. Okay, so let's take this original equation as plus over here. Okay, so for it means that y will be equal to, if you just solve it in terms of y, so y will be equal to here I will put just y will be equal to, okay, x goes there, c minus x, and then divided by cosine hyperbolic, so it will be c minus x divided by cosine hyperbolic x, and then I will need to take the arc cosine. Okay, so I will put arc cosine here, arc cosine here, and then I will execute it. So it was, this is this function. So let me take a variable, say y1 equal to this right hand side of this equation. Okay, so y1 is this. Okay, arc cosine c minus x secant hyperbolic x. So now I want to plot this general equation, general solution. So for if I want to plot the general solution, it means that I need to take a set of values and then provide to this function, and then that function should be plotted against the values of x. Okay, so in this case I will put plot, and then I will use two more functions, evaluate and table. Okay, and then I will put this function y1. Okay, and now I will put the range of values for c. So range of values for c, maybe I can choose 0 to 10. Okay, 0 to 10, the range of values of c. Enclose it into the curly brackets, and then I close the bracket for table, close the bracket for evaluate, and then I put the range for x values. X values maybe I can put from 0 to 2 pi. Okay, 2 pi. Okay, and then I close the bracket and then I close the bracket. Okay, so I hope if I entered it correctly, then this will execute. So now I execute it. So I can see that nothing happens over here. The reason is I forgot to specify what is this. So this is C. These were the values of C. So now I put C over here and then I execute it. So now I can get this kind of plot. So this is a plot for a range of values of C from 0 to 10. By default, the values are increased. Values of C are increasing from 0, 1, 10, and then therefore I will get about I don't know, maybe 11 curves. So maybe if I put like 3 over here, so how many curves I will get? 4 curves. So this means that I will get values of for this plot from 0 to C is equal to 0 to 1 to 2 to 3 to something like this. If I want to specify the range, so for example, if I want to plot from 0 to 3 in a range in an increment of 0.5, so I will put a third argument over here as well as 0.5. So then I will get like this. So in this case, I will get a plots of for the values of C from 0 to 0 0.3, 0 to 0 0.5, 1, 1.5, something like this in the increment of 0.5. And the plots are from arranging in the x values are arranged from 0 to 2 pi in this case. Okay, so in this case, I use these two functions, evaluate and table. So these two functions, yeah, I think this is one of the method for plotting the general solution of the function, which you get from the ordinary differential equation. In the case of second degree, second order or higher order differential equations, you will have more values of constant C1 and C2, C1, C2, C3. So in this case, for each parameter, you will add a set over here. So this one will this will be for C1, then the next one will be for C2, and then like that. So how about the table and evaluate why these functions were used? As I said, this is just one of the method to show the these different curves on one plot. So basically the table command, table function produces the range of values for C. Okay, and evaluate function actually forces this function inside to evaluate or to calculate the values. Okay, for which are provided by the table function, and plots it. Okay, so in this way you can find the range of you can draw the general solution of the curve. So if you just want to draw just one curve, then you will not use then you will not need to put the evaluate and table. Then you will just input the specific value of C into the equation, and you will just plot it. So if you want to plot a range of curves, then maybe you can use this function. Okay. Well, another, or if you want to plot some specific values, not following some simple some sequence of the values of C. For example, one value of C is 0, the other value of C is 1, the other value of C is 3, not 2. So in that case, then you will have to put this function into the brackets for separate values. Okay, so let me show you over here. So for example, if we want to plot these curves for 0, 2, and say 3, 0, 2. So 0, 2, and 3, there is no constant increment. Okay. So for example, in this case, then I will let me copy and paste this command over here. So then I think in this case I don't need to use this plot and evaluate, and even I will not need to use this y1. For y1 I will replace it with this yes, here. Control V. Okay, and then again Control V, and then again Control V, and let me make changes. So first value C is 0. Okay, second I said that is 1, and then the third I said that is 4. Okay, not 2. 1, 0, 1, and 4. So I must enclose this set of functions into this in bracket, and now I don't need this. And that's all. Hope it is correct. So I will execute this command. Yeah, it doesn't work. So maybe I made some mistake. So I need to check. Plot arc cos 0 minus x secant hyperbolic, and then yes, this was the bracket, and this is the bracket was, and this was the bracket probably. Arc cos 0 to c minus x, arc cos, and then secant hyperbolic x. Yes. I think this bracket should be here. And this bracket should also be here. So you should execute it. No, it doesn't work. Yes, so maybe here. Yes. Okay, so no. Okay, to check the error, I think it is better for me to just remove everything. So because I know that in this bracket I have to provide the function. Okay, so I take this function which was previously working over here. Yeah, exactly this one. Control C, and then I paste it here. Control V. Okay, and then again Control V, and then again comma, and then Control V. So I have placed it exactly according to our plan, 0, and then C should be 1, and then I said it's 4, 0, 1. And so let me try it. It still is not working. So it's because I have forgot to place a bracket over here. Okay. Yes, now it works. So you can see that now I have got the values at specific values 0, 1, and 3. So which, if we want to see which one is 0, which one is 1, then we will have to plot the legend. So this can be plotted like this: more legends, and then you can say it's formulas. So yeah, so with the 0 it will be this value. Okay, for 1 the color is this, and then 4 the color is this. So this means that the greater the value of C, the more closer this curve is near this x-axis. So I hope that this short tutorial will help you understand how to plot the general solutions of the differential equation when you have to plot the range of values of C using one command. Thank you.